And let's go ahead and start. All right, guys. All right, guys. Well, welcome back. We're back in another session. Um, guys, we left off, right? We left it off. We're still in chapter 8, implementing Ethernet virtual LANs. We were going ahead and going through and following through VLAN communication, broadcast domains, um, 802, 802.1q trunking, right? By the way, guys, I encourage you guys to look up RFCs. Okay, whenever you learn about a new theory or new technology, please take the time out, take the 30 minutes that it takes to actually read an RFC, right? Combined with watching a YouTube video. I know it's a lot of wordplay in the a lot of words to digest, a lot of big words to digest in the RFCs. But please read it. Please read those documentations that go over some of the words that are theories in this chapter. We went over VLAN tagging concepts. We touched on that. We touched on we touched on how that VLAN tag looks within an actual frame, right? Using Wireshark. Where we're going to now, and this is the last part of this section, right, of the chapter that we need to express, right, is we need to talk about forwarding data between VLANs. Okay, right? So why would we need to forward data between VLANs, right? Maybe in our architecture we separated these broadcast domains for specific reasons, right? Typically, whenever people create broadcast domains, they have assigned roles or groups or what have you. Maybe we have the sales VLAN. Maybe we have the engineering VLAN. Maybe we have the server VLAN. Maybe we have the IoT devices VLAN. Maybe we have the um, physical security devices VLAN, right? It's always associated with a role, group, number, whatever the administrator creates it for, right? We want to, overall, we want to limit the broadcast available for that domain. Okay. All right. So we set it up, right? But we can communicate between, we can communicate within a VLAN, within that broadcast domain, even over multiple switches, right? And we proved in our last session we are able to do that, right? Between a multi-switch link using a trunk, right? Trunk uses the concept of VLAN tagging, right? To go ahead and make sure that traffic that sources from one switch is sent over, right? Sent over that trunk to extend that broadcast to the same VLAN, right, on the other side of that peer switch. Okay. But what if we wanted to communicate between different VLANs? Okay. Typically in an enterprise environment, you guys would see communication between different VLANs, and how they would achieve this would be a layer three, a layer three instance that exists within that network, within that architecture. Okay. Because again, layer two logic uses MAC addresses, right? And communication using MAC addresses only exists within that broadcast domain. Okay. If we want to go beyond that, right, we need to go ahead and turn our frames into packets. Only way we can do that is if we have a layer three instance. Okay. So, but we see here we have VLAN 10, we have VLAN 20. We need to now create subnet 10 and subnet 20. Of course, we have that, right? We have 10.10.1.0/24. That's for VLAN 10. Then we have VLAN 20, 10.20.1.0. Okay? We have that set up, right? So let's go ahead and um let's go ahead and both prove how we would route packets between VLANs on a router, right? In this lab, here's what we're going to do. We're not going to implement placing a physical router, right? Maybe in our environment we can't afford another device, right? We have to wait till the next budget. right? To go ahead and pitch it to your CTO to say, hey, you know, I know it's not I know it's not end of life or end of support, or maybe the budget is out. We need to layer through device. Well, you actually don't need the router. You can go ahead and use your switch because it may be a switch with multi-layer capabilities. This is what we have, right? So we have our Cisco switch. We're grateful we're able to, implement layer three instances using SVIs, right? Right? And SVIs stand for switch virtual interfaces. Okay. What that does is that creates a layer three instance on a switch using software. Okay. Communication that comes in via the data plane, right, is sent up to the control plane, right? And the control plane responds and says, hey, let me go ahead and send this to my routing information base. Now that you've enabled, right, a layer three instance, I now know what to do. I'm going to go ahead and process it, right, encapsulate and de-encapsulate all the frames that come in, right, depending on the layer, and start that communication, right? Whether that communication is same layer communication or that communication is adjacent layer communication. Okay. With both layer two and layer three enabled on this switch, now you're able to move packets, right, between VLANs, right? Let's go ahead and first prove what it looks like without a layer three instance on the switch. Okay. So I want to go ahead, right? I want to go ahead and ping PC3 to PC6. Okay. PC3 is in VLAN 10. Okay. I'm sorry, PC3 is in VLAN 10 and PC6 is in VLAN 20. Okay. Let's go ahead and let's see first if they can ping each other. All right. So PC3, we're gonna give it an IP address every time. And by the way, just in case if you guys have your own EVE-NG lab, every time you close your lab, right, the configuration for your switches, your routers, your firewalls, that configuration more than likely will stay. It typically stays. For your virtual PC, since that is a Docker that comes with EVE-NG, great feature, it will lose configuration every time. So you would need to configure, right, the IP address every time. Okay. So let's do this again. I think we gave this 10.10.1.3 last time. We're going to put it in a /24 subnet. Okay. And then we're going to give it a gateway. 10.10.1.1. Okay. It's going to do its GARP. It's going to announce, hey, I'm this. Is anybody else that? Is anybody else that? If we don't get any responses, boom, right? This tells us it has configured, it has been configured, right? Excellent. Now let's go ahead and configure an IP address on PC6. Okay. Um, let's do the same thing. Oops, mistype, apologies. IP, and then we're gonna do 10.20, I apologize, 1.2. Okay. So then we're going to do /24, and then we're going to go ahead and give it to its gateway, 10.20.1.1. All right, let's go do its guard, see if it exists. It does not exist. We are good to go. All right, so let's go ahead and let's pull up PC3, and let's try to go ahead and ping PC6. So we did 10.20.1.2. Okay, as you guys can see, right? As you guys can see, trying to ping from PC3, right? We are getting a host not reachable. Okay, all right. So that means, and we don't even have to even try to ping from PC6 to PC3. That is because again, we don't have no firewalls in place. This is telling us, right, that initiating traffic from the source from PC3 cannot reach PC6. And we know exactly why, right? There are no layer three instances, right, on our switches or in our environment or in our architecture. Okay. Let's go ahead and add that and see if we have different behavior. Okay. So how would we do that, right? In chapter 8, you guys are not going to learn how to create SVIs, okay? Chapter 8, it explains you guys to go ahead and utilize implementing a router. It also talks briefly about implementing an SVI, but you guys won't learn about SVIs or what have you till later chapter. For the purpose, right, of this session, I will be implementing an SVI, and the focus we want to see is the thing we want to prove is routing packets between VLANs, right, with a router. And we are essentially with SVI adding a router slash a layer 3 instance within our architecture to see that routing through that routing through those switches, right? Routing those packets through VLANs. Okay. So let's minimize this. Let's go ahead and add our switches. Okay. So we have switch one, right? Every time we log into a switch, let's go ahead and confirm our configuration. All right. We jumped on this device because we want to add a layer 3 instance. Let's just make sure a layer 3 instance doesn't exist on this switch. Okay. All right. So we're going through this slowly, right? We see our configuration, see the host name, boot start marker, end start marker. AAA is not configured. Let's keep going. All right, we got a couple of IPCEF. We got spanning tree, right? That's enabled. We have LLDP configured. We did configure that the last time, right? We have our interfaces. We have our trunk configured, okay? We have our VLANs figured for our different interfaces, right? So that's set up already. We have forward protocol configured. We have HTTP server, HTTP secure server configured, right? We have a SSH server algorithm encryption configured, right? And the same thing for our client. We have that set, okay? We have our banner configured, right? That comes by default with these images, all right? And we have our line con, line aux, and line VTY. They exist. We don't have no sub configurations for them. Okay. Well, there's one that comes by default, and that's just login. Okay. Again, that comes in with these images. So we've proven we do not have a layer 3 instance, right? Whenever you create an SVI, okay, for it to be functional, okay, and actually route packets between VLANs, we first need to have the layer 2 instance of that VLAN, right, to exist. So first, we want to go ahead and do VLAN 10. Let's see if VLAN 10 exists on the switch. We know it does, but trust but verify. Okay. All right. So VLAN 10 and VLAN 20, because we want to do that too, they both exist. Okay. Um, so they both exist on this switch, right? So now let's go ahead and create the layer 3 instance, right? So since we're going to make a change to the switch, this is a global change, right? We need to go to global configuration mode. So let's do config terminal. Okay, so we're here. We're in global configuration mode, right? So how do you think we would go ahead and configure that switch virtual interface? We would do interface. Let's do a question mark, right? And as we can see, the switch gives us the option, right, to configure interface that's dedicated to a VLAN, right? And of course, I'm going to say Catalyst VLAN. So let's say VLAN, and let's do it with a question mark. And now it's telling us, hey, VLAN interface, and what's the number you want to assign to this VLAN interface? We're going to do VLAN 10. Okay? All right. So what we see now is we saw a syslog message that pops up that tells us, hey, line protocol, layer 2, which you guys learned, right? In part 1 and part 2 of this book, right? Line protocol means layer 2. So VLAN 10 is down. Okay? All right. So let's go ahead and add an IP address to it. All right. And let's do 10.10.1.1 slash, I'm sorry. We actually have to type out and I'm thinking I'm on a VPC, right? We actually have to type out the subnet mask. So let's do 255, 255, 255.0. Okay. And then typically, right, on these old images, right, and I think on the new images as well, any layer 3 is going to be automatically off. Okay, let's do a no shut, and let's see if we get a sys message. Okay, so security reasons, right? Network security reasons. Typically, whenever there's a layer 3 instance that is created on a switch or even your routers, right, on your Cisco routers, they're going to by default be off. Okay. Um, Cisco, right, and typically many vendors, they don't want somebody just plugging in and forwarding packets, right, with the outside world, right? You have to consciously make the effort to enable that. Okay. So we went ahead and enabled that, right? Let's see. Let's go ahead and see if PC3, since it's VLAN 10, if it can ping interface VLAN 10. Okay. Let's go ahead and pull up. All right. Let's go ahead and pull this up. Let's say 10.10.1.1. Let's see what happens. Boom. Right. So now we're getting responses. Right. We're working. We're all good to go. Okay. So now we can reach our layer 3 instance, right? But before we communicate with another VLAN, that VLAN needs a layer 3 instance as well. Okay. Similar to a router, right? And let me pull up the infograph from the book. Okay. So let's zoom in. Right. I don't want you guys to get too lost in the sauce thinking about these words. Right. So right here, right? We created VLAN 10, right? That's the layer 3 instance for that broadcast domain. But for the router, right? The router being the switch virtual interface for VLAN 10, we also need an instance for VLAN 20. It needs a way to forward that traffic between VLANs. So we also need to go ahead and create the SVI for VLAN 20. So let's go ahead and do that. Okay. So let me go ahead and move my pencil. Let's get back on the switch. We need to do the same thing for VLAN 20. Okay. So let's do interface. Okay. VLAN, and let's do 20. Okay. We're going to get our syslog message. Our syslog message is going to say, hey, layer two is down. Layer 1 is also down. Right. And let's verify what I told you guys. Okay. Let's do a do show run. Oops, run interface VLAN 20. Okay. So like I warned you guys, like I told you guys, right? Network security feature, typically on switches, you guys would even see this on the Cisco 9Ks, even the 4Ks and the Cisco 6Ks, right? You are going to see whenever a routed interface, a layer 3 interface, or an instance is created on a multi-layer switch or exists on a router, right? It's always going to be shut down initially. Okay. We don't want somebody, a bad actor, plugging in and immediately start forwarding traffic. Okay. All right. It needs to be a conscious effort for the admin to enable this. Okay. So let's go ahead and what's one of the things we need to do first? We need to assign an IP address. Then we need to go ahead and enable this interface, right? To forward packets, which means we need to undo the shutdown command, right? Or remove it, right? So let's go ahead and assign an IP address first. Let's do 10.20.1.1, okay? And of course, whenever we are configuring a IP address on a Cisco interface, we need to type out the subnet mask, right? In decimal version, okay? All right, excellent. So now we configured the IP address, we have that. But before we can test, pings or what have you, we need to go ahead and also enable the interface so that layer 1 and layer 2 is enabled so that it can receive layer 3 traffic, okay? Let's do a no shutdown. Then we should get syslog messages that pop up and tell us layer 1 and layer 2 is up. And of course, we got that. We got the syslog message up down, interface VLAN 20 has changed to up. Okay. And it tells us now that layer 2 is up. So we're good to go. Okay. All right. So with that being said, we should now have a routing information base. Okay. Let's do a show IP route. Let's look at that routing information base. Routing information base is another term for a routing table. Okay. So we see it here, right? We have two things, right? And I know I'm jumping ahead for forward chapters, but for the sake of this lesson, I want to go ahead and go over it while we're here, right? So we have different codes, okay? These different codes, right? They describe, right? They describe different meanings to letters and of course symbols or what have you that you'll see in the routing table, right? L stands for local, C stands for connected. In future chapters, you guys will learn a lot more of this. My favorite, egrep, egrep external, OSPF, inter area, uh, external type 1, type 2, so much fun stuff. We can have a field day with that. We will talk about that later, right? Let's talk about, right, creating routes on this router, right, and what they mean. So I talked to you guys about the codes, and of course you would have to read every meaning, right? Let's talk about this, right? And then routing information base, if you guys don't, right? Because again, all a switch is whenever you create a layer 3 instance, it's another host on the network. Okay? It's another host, and its functions is to route packets. Okay? Well, it also being a host, it needs, right? Let's say in you guys' network, you want it to route packets, right, to the World Wide Web, right? It also needs a gateway, okay, to go ahead and forward traffic just in case the subnet does not exist on this network, okay? That's why the term gateway of last resort, right? It means, hey, if I can't find the destination network in my in my routing table, that means I don't know where to send it. I'm just going to send it to that next hop that I have configured has the gateway, and it'll go ahead and send that packet where it needs to get to. Hopefully, okay. So whenever you don't have your gateway set on your multi-layer switch or your Cisco router, it's always going to say this. Okay, keep that in mind. All right. So typically when we have routes in Cisco iOS, it's going to give us the supernet. Okay, we created the subnet, but it's going to show us the supernet, right? It's going to say 10.0.0.0/8, the supernet, right? For any 10 network, it's going to say, hey, it's variably subnetted. Okay, right? So the supernet has been subnetted, right? What we configured, right? We created two subnets, but it's telling us four, and I will explain why. And it's telling us also it has two subnet masks, right? Okay. There's two subnets, okay? But, right, we have different type of routes. We have a connected route, we have a local route. Exactly what it means, right? We have a connected route. What that means, right, is that this route is connected to the router because it was configured here. It was configured on this device. Local route, right? And as you can see, it changes. 10.10.1.1, that's an interface on our device, right? This is telling us, hey, this host exists right here. I know how to get to this host, right? Because it's, of course, it's /32. So it's identifying, right? It's identifying this host. Whenever you see a /32, that only means one host within a subnet, right? 10.10.1.1 is our VLAN 10 switch virtual interface, right? And it's telling us it's directly connected, right? Remember, of course, C, connected. It's directly connected to this device, and it exists on VLAN 10. Okay? That's all that means, right? The subnet is connected to this device, and the interface is also connected to this device. Okay? All right. Now, let's do some checks, right? Let's see if we already tested pinging um, VLAN 10. Let's try to ping VLAN 20 from PC3. Okay. So just so you guys are tracking, we're using this as our source and this has our destination for now for the test. Okay. And guys, as we continue to move on in these sessions, I'm going to speak in terms of source and destination. That's how I want you guys to speak in your professional careers. That's how I want you guys to attack anything moving forward. Okay, so let's go ahead. Let's do this test. So I'm going to go ahead and test pinging VLAN 20, right? That exists on switch one. So we're going to do ping 10.20.1.1. Okay, we're getting pings. Let's talk about a few things here. What did the switch do? Well, what the switch did, right? Let's pull up the switch. So the switch has its routing table, it has its routing information base. It knows, hey, traffic from PC3 and VLAN 10 needs to go ahead and send traffic to VLAN 20. Okay. I need to first send it to VLAN 10, right? Because the gateway for PC3 is this bad boy right here, right? Because PC3 is again another host. It doesn't have a route configured on it for VLAN 20. So it's going to send it it's going to send it to its gateway. The switch virtual interface that VLAN 10 exists on, it's going to say, oh, okay, excellent. I'm going to go ahead and send this to, I'm going to go ahead and look at my routing table and say, hey, where do I need to forward this to? Well, I need to forward this to VLAN 20, right? And it's going to go ahead and send this to the layer 3 interface for VLAN 20, right? At first, it's going to look at its connected route. It's going to say, hey, 10.20.1.0, right? For this IP address, for a PC6 IP address, I have a connected route, right? And this exists for it, right? It exists on my switch, right? See, whenever layer 3 instances are forwarding traffic, right, via layer 3, they have something called a um, route packet preference, right? So first, it's going to look at the prefix. Then it's going to look at the subnet. Then it's going to look at um, the metric of the route. And look at the metric, right? Then it's going to look at the cost or what have you, right? And we're going to go over that in future sessions. I need you guys to understand, right? There's criteria that needs to be met before traffic is sent, right? All traffic has a specific metric. Static routes has the lowest metric by via software that is configured. Okay, you can of course configure manual metrics, but by default, in terms of route weight, okay, static routes whenever you configure it, it has a better cost or metric versus dynamic routing protocols. Okay, so it's going to first look at the prefix, right? It's going to look at the metric of the weight. Then it's going to look at the cost, right? The cost it varies between different protocols, what have you, and go from there. Okay. So it's going to look at it. It's going to say, hey, this is a static route. We are going to go ahead and ship it here. And of course, right? Our layer 3 instance, we're going to ship it there, right? 10.20.1.1. And then it's going to do, it's going to go ahead and say, hey, I know where this exists, right? It's going to do that ARP. It's going to say, hey, who is 10.20.1.6? Please respond to, hear me out, guys, 10.20.1.1. See, respond to the gateway, right? Because I may have lost your MAC address, right? Because this is a layer 3 instance. Even though it's on a multi-layer switch, the layer 3 instance, I need to know how to encapsulate this packet and turn it into a frame. Okay? All right. So when it does that, it's going to go ahead and get the layer 2 information and say, all right, I know how to bundle it. MAC address is going to be entered, right? It's going to consult with this MAC address and then forward that packet. Okay. So let's see if we can ping PC3 to PC6. Okay. Let's try it now. And let's double check the IP address. I had PC2 there. Okay. I had two. So I should have gave it a 10.20.1.6, but all good. All good. We have it now. Right? Let's see what happens. Okay. We're getting a ping. Why did that work? Right? Well, here's how it worked. Right? We have a layer 3 instance right here, right? For both VLANs. Remember, last session, we now have, right? We now have a trunk between both switches, right? Between both switch 1 and switch 2. So now tagging happens here. What does that mean? What that means is that if the broadcast domains exist on both of these switches, and whenever we configure a trunk, right, and VLAN tagging 802.1q is now enabled, right, this means if a broadcast message for a specific VLAN, right, is received, right, on any of these switches, it's going to extend beyond the device and be sent through the trunk, right, and be sent through its peer to reach more devices, right, depending on how many devices are configured for that broadcast domain. What does that mean? So PC3 on switch 1 can absolutely reach, right, VLAN 10 because of the trunk. But now that we have a layer 3 instance, VLAN 10 can reach PC6 because we have layer 3 instances, right, for both VLANs, right, at layer 2, that can go ahead and route packets between those different broadcast domains, right? And so whenever that traffic is being sent from one layer 3 instance to another, it's going to go ahead and see in terms of source and destination, like it did for layer 2. And now that we extended the layer 2 aspect, now we can communicate via layer 3 as well. Okay. All right. What happens, right? Let's test this out before we leave. What happens if we go to switch 2 and do this, right? Because we can't just talk about, in the working state, we also have to talk about it in the broken state. What happens if we do this? We remove the VLAN 20. Let's go to switch 1. I don't see no syslog messages, right? Maybe the syslog messages that pop up, right? So now, let's see if I can still ping PC6. I'm getting a timeout. I can't reach it. The layer 2 instance needs to be in place for layer 3 to work. That extends the broadcast domain. You understand? You guys learned about encapsulation and de-encapsulation. Before it gets to layer 3, before it gets to layer 2, it needs to hit layer 1. When it leaves layer 1, depending on what type of media you use, it gets to layer 2. Layer 2 is the rules, right? Hey, Do you have a source? Do you have a destination MAC address? Okay, excellent. All right, excellent. This is destined for me, or is it not destined for me? If it is, excellent. Let me go ahead and de-encapsulate it some more. Then I'm gonna move forward, right? And look at the IP address. Look at the packet, right? The PDU has changed, right? The PDU has changed. Okay. So let's revert that. Let's go ahead and add it back. Let's do VLAN 20, right? For good measure, let's go ahead and add that back. Interface gigabit 0/2. Switch, switch port access VLAN 20. Okay. All right, and let's make sure we fixed our lane. Okay. See what happens. See if we can ping it. If it's all good to go. Let's see if we're not missing something. We probably are. Okay, let's double check our config. All right. Let's see show interface trunk. Okay. And let's do, so we got that there. And let's do a show VLAN brief. All right, excellent. So we got that. It exists. It's all good to go. Let's go ahead and let's take a look at switch one. This one is the show interface trunk. All right, excellent. Okay. Let's go ahead. All right, excellent. So typically it takes some time, right, for the Dockers to match up. But yes, because of course this is all software still. Now it is working, right? But that's a scenario where it can be in the broken state. Okay. So when you guys are learning, I want you guys to slow it down so much, right? Slow it down so much, right? When you guys are learning. And of course, have that OSI model up. Okay. Remember, right? Every device in the network is a host, right? So your PCs have the ability to have a ARP table. It's a layer three instance. It's a layer three device, right? They're not gonna have a MAC address table, but they will have an ARP table. Okay, they work the same way. Okay, right? And that is forwarding data between VLANs. In chapter 8, of course, you guys also learned, of course, how to configure a VLAN. Okay, we're gonna stop right here. I think we're at our 30-minute mark. Um, and I will see you guys in the next session.
All right, appreciate it, Dave.
All right, guys.
Thanks, Dave.